Welcome to this session about Grumplexes in Kubernetes with me, Linus Hakason, Solutions Engineer with SnapLogic. Before we dive into the context and the agenda of this session, I want to just give a brief summary of the architecture of SnapLogic and what is a Snaplex. So the SnapLogic architecture is made of a runtime and a design time. So the design time is a cloud-based interface that lets you design and monitor and manage your SnapLogic assets and pipelines from a central location. The SnapLogic runtime consists of either CloudPlexes or Groundplexes. In SnapLogic, we refer to them commonly as Snapplexes. So the difference is that a CloudPlex is the environment that runs your integrations hosted by SnapLogic. And a Groundplex is when you as a customer, you deploy and manage those nodes that run your integrations and connects to your endpoints. In this session, we will have a look specifically on how you as a customer can manage and set up the Groundplexes in a Kubernetes architecture. Groundplexes can be run either on Windows or Linux environments, as well as containerized and be run in Docker or in Kubernetes. So in this demonstration, we will first create a Snaplex definition in the SnapLogic Manager. We will then download a Helm chart that allows us to define the architecture of the containers in a Kubernetes cluster. Then we're going to download the Snaplex configuration that is specific to the Snaplex we created in the first place. We will then edit the Helm chart to include the link to your Snaplex configuration, as well as some properties around the requirements and resources for our nodes. Then we will create a Kubernetes cluster as well as a separate node pool for that specific deployment. We will then install the Helm chart, which means that both a feedmaster and execution nodes of SnapLogic will be installed in that particular Kubernetes cluster. Then we will take it one step further and apply autoscaling policy to our cluster. This means that if our execution node in our example gets increased memory consumption, or in this case actually processor-based consumption, we will automatically add a new pod to the cluster of that particular node, in this case, the JCC node. And also the infrastructure that powers the node pool will also add another machine to the environment. So what we will do to try that out is we will actually execute a pipeline to see how that autoscaling policy behaves, both in autoscaling the instances up as well as down when the reduce in load happens. Okay, so I'm now in the SnapLogic Manager under the Linux project space in the project called Shared. So where you create your Snaplex defines where users can access it and where users needs to be in the project spaces in order to be allowed to create pipelines that actually run on your Snaplex. So here what I'm going to do is I'm going to go to the Snaplexes asset and I'm going to create a new Snaplex. So in this case, I'm going to call it my testplex. And for environment, I'm just going to write cube here for this case. That's all I need to do. And I'm going to press the create button here in order to have it created. Now, if this was any other type of installable, if this was on Linux, if this was on Windows, or maybe even if I was just running a single Docker container, I would need here to download the actual distribution that I wanted to run. But in this case of Kubernetes, I'm just going to leave this with no further action and just cancel down this Snaplex dialog. So in my particular case, I've decided to run my Kubernetes cluster on Google Cloud Platform's GKE or the Google Kubernetes engine. The steps that I'm going to take you through is somewhat dependent on the actual provider of the Kubernetes environment, but the same type of steps applies whether you're running it on your physical private on-premise server or on your laptop, perhaps using something like Minikube, or deploying to Azure or Amazon or other cloud providers managed Kubernetes engines. So the first step I'm going to do is I'm going to go into my Kubernetes environment. So here I have a completely fresh project where I haven't done anything except obviously creating a project called my first project that has this unique ID here, Memetic Encoder. So what I'm going to do is I'm going to use the terminal or the shell of Google's provided tool here. So I'm not going to be doing this on my own laptop. I'm going to do this without having to do any preparations or setups and just using whatever the shell of Google allows me. So the first thing I want to do is to download the Helm chart template for the SnapLogic GroundPlex setup. And this is something that is provided on the SnapLogic documentation. So if I go here to the SnapLogic documentation where it says deploying Snaplex containers in Kubernetes, it walks us through the setup of what I just did, going through the actual creation of the Snaplex, as well as providing a reference to that actual zip file that holds the templates for the execution node and the Ultra and the FeedMaster container, and how they kind of have their relationship. But we're going to do this in a completely scripted way. So what I'm going to do here first is just creating a temporary space for me here called Snap. So I'm going to just go into that folder. So this is where I'm going to use the wget command to go and download that specific Helm chart that we just viewed on the documentation page. So the next thing I want to do is just unzip that zip file so we get the complete Helm chart content. So let me just do an unzip of that, and here we can find all the templates and different values and configurations files within our Helm chart. So the next thing we're going to do is to get the configuration URL of your specific Snaplex. So what I'm going to do here is I'm going to paste my curl command right here, and here is where we need to extract and replace some of the values. So one of the things we're going to have to replace is the name of our Snaplex. So in this case, I call this my testplex, I think, my testplex, something like that. And then for the project, this is in my shared project. Now, if you put this on the top of your organization, you don't need to add this project space here, but in my case, I put it in my Linux space. And then for the org, I'm using an internal demo org here called Connect Faster Inc. And then finally, I just have to provide my particular username here, and using that flag here with the U flag, I'm going to have it to prompt me to ask for my password, so I don't need to hard code my password. So there's my username, and now I just have to enter my password right here. Okay, so I now have a specific config object here. So I'm just gonna go and copy this nice URL right here that ends somewhere here. And this is what I'm gonna need to enter into my Helm chart that I downloaded. So let's go into our Helm chart right here. Again, we can see the different files we have. We're gonna explore some of the content here. Initially, we're gonna go into the values.yaml file. So I'm just gonna open my editor here. And here's a couple of instructions I can set. I can set the initial number of execution nodes, so the JCC counts, as well as the number of feedmasters. So in my case, I'm just going to set them both to 1. I'm going to use the latest version of the Snaplex Docker container. And then here under the Snaplex config link, I'm going to paste my URL here from the curl command that we just did to get that configuration for my specific Snaplex. Okay, so I'm just going to write that and save the file. Now, the next thing I want to do is to specify in the Helm chart how much resources my feedmaster and execution nodes should consume on the actual pod of the node of the cluster. So this is a Kubernetes specific thing, and it determines and impacts whether or not SnapLogic nodes fits on the actual Kubernetes nodes. So it obviously depends on what type of node machine type you want to have for your cluster. So in my case, I've gone for a 2 vCPU and 11 GB of memory per node. In the case of Kubernetes, most of the providers will install a couple of add-ons, as well as Kubernetes itself installing a couple of add-ons, which means that if you have a 2 vCPU instance, your applications will not have the ability to have and occupy all those resources. So what I'm going to do is I'm going to go in here to our templates folder, where we have the templates for both our execution node and our feedmasters. So I'm going to go and edit first here the feedmasters template. So this is where we see the request that this particular deployment should have on the node, or in the pod rather. So here I'm actually going to reduce the CPU request to just almost more than half of the actual 2 vCPU, so 1300. I'm going to leave the memory to 8 because I'm actually going to select an instance type that has more than 8 GB. I'm going to select one that has 11 that Google provides. So I'm going to do the same for the non-feedmaster deployment template. So I'm going to go exactly do the same here. So I'm going to edit this one as well to 1300. All right, so there we go. So we can just go back to our kind of original folder. So now what we've done, if we just take a step back, right? So we've basically created a Snaplex. We've downloaded the Helm chart. We've downloaded the Snaplex configuration that is specific to our org and that specific Snaplex that we just created. We also edited the Helm chart in order to point to that specific Snaplex configuration link, as well as the two resource requirements for both the execution node and the feedmaster node. So the next thing we want to do is now actually create a Kubernetes cluster and start deploying and installing this Helm chart with all the resources so that we can actually start getting productive with our Snaplex. So the first thing I'm going to do, and this is a Google specific thing, using this terminal, is I'm going to just set an environment property here, which is the actual project that I'm working in my Google Cloud environment. So I'm going to set this here to my first project, and then I'm going to also set the actual compute zone where I want to provide my cluster and have this as an environment property as well, so that everything that I create kind of defaults to being in the north of Europe in this case. So next, I want to actually create my Kubernetes cluster. So I'm using, again, a Google-specific command here to create that first cluster. I'm going to call it SnapLogic, and I'm going to say that it's only going to have one node in it. Now, what Google will do is will provision a default machine type there with just a single vCPU. And the reason why I do this is because I just want that default node pool that will be created in my cluster to have the minimum impact in terms of the capacity there, where the actual masters of the Kubernetes cluster will run. Then I'm going to create a separate node pool where I would have exclusively to my actual execution nodes and feedmaster node to run in. So we're just going to have to wait 2 or 3 minutes for this cluster to be created. Okay, so the initial cluster has now been created for us. So just to see visually what we have been doing, we can go into the Google Cloud Kubernetes engine. And in the clusters page, we should now see the SnapLogic cluster here with just a single vCPU of just less than 4 GB of memory. So let's go and have a look to there. We can see that we have one single node pool here, which is the default node pool with a very small machine type. So what we want to do now is we want to create another node pool that is going to be dedicated for our specific GroundPlex nodes. So I'm going to run another command here in our command line, which is creating a node pool that I'm going to call GroundPlex. So I want the number of nodes to be 2 because the machine type that I'm going to be used is an N1 high mem2. That means that it's a Google type that has a 2 vCPU and around 11 GB of memory. So while SnapLogic licensed nodes are 2 vCPU and 8 GB of memory, that means that we're going to have one node on, so one SnapLogic node on each actual infrastructure node in the cluster. So that's why we're going to have 2 nodes by default, one for the feedmaster to provide ultra capabilities and one for the execution node. We're also going to say here that we're going to enable auto-scaling. And the auto-scaling needs to have a minimum of 2 nodes, and that's our default initial number of nodes, and it's also going to have a maximum of 4. We're going to come later into this demonstration to how we actually allow it to scale up and what kind of metrics it looks at. And we're also saying here that the cluster where we want to attach this node pool is the SnapLogic cluster that we created before. So here we're just going to wait a couple of minutes as well to have this being created. Okay, so we can now see that we have a new node pool here called GroundPlex. You can see that we're using another type of machine type, and currently we have a 2 node, but an auto-scaling between 2 and 4 nodes. So we just go into that GroundPlex quickly. We're going to see that we have those 2 nodes that are ready to handle our workload. But as I mentioned before, the CPU that is requested by those 2 nodes are actually almost 0.4 and 0.2 vCPU, which means that the actual amount of CPU that our runtimes or execution and feedmaster nodes can occupy are not going to be those full 2 vCPUs. And that's why we had to come into the templates of our Helm chart in order to get those requests down a bit so we can actually fit them on the nodes. And again, this is just related to my specific way in this demo to set up the SnapLogic GroundPlexes in this specific Kubernetes cluster, and may be different to the machine types and allocations and resource requests that you have in your case. So before we actually deploy and install our Helm chart here, what I want to do is just come into the the Cloud Shell here again and set the namespace that I want to be working on. So I'm going to create a separate namespace here called SnapLogic in my Kubernetes environment, because that's effectively where I want to install my Helm chart and deploy my nodes. So we can have this new namespace created for us, and now I'm going to install that Helm chart that we have now configured with our link to the configuration of our Snaplex, as well as the updated resource requirements for our 2 templates for the nodes. So I'm going to install that in the namespace called SnapLogic. Okay, that was very quick. So what I want to do now is just use Kubernetes to switch to my SnapLogic namespace, so that when I provide and perform any type of kube control operation, it's going to be specific to my namespace. So just to confirm what's going on, I can write kube control get pods, and I will see that both my feedmaster and execution node containers have started to be created. If I want to get more logs and details, I can do something like kubectl describe, and then I can just have my, for example, my execution node. Oops, I forgot the word pod there. So let me just go and copy this command real quick. And then we're just going to enter describe pod right here. So now we can see that we were able to pull down the latest Docker image, and we have now finally successfully started the Snaplex. If I just run that command once again, I'm now going to be able to see that both my containers here are running in my pods. So the next thing I want to do is actually enable the auto-scaling specifically for my execution nodes, because in this case, in this demonstration, I only want to do scaling on my execution nodes and not my feedmaster. So I'm going to use, again, the kube control here to add an auto-scale for my SnapLogic JCC deployment. So I'm going to say that I want a minimum of 1 pod running and a maximum of 2. So this also will translate to the number of nodes, because again, in my particular case, 1 pod is only fitting in 1 node. So if I scale up my pods, I also automatically need to scale up my nodes, which is why we added the auto-scaling, enabled auto-scaling on the cluster itself as well. And here I'm going to say that as long as the CPU percentage gets over 50% of my node, of my execution JCC node, then I want to add another one. Okay, so if I want to, I can go have a look to see what the status are at the moment. So I can run the get HPA, which is the horizontal pod autoscaler. So I can see that currently we haven't collected metrics enough to know whether or not the target has been reached, which is the 50%. But we're currently on min 1 pod and max 2 pods. So if I open up my dashboard of my SnapLogic environment, I should now see healthy statuses for my 2 nodes in my GroundPlex running on Kubernetes. So I'm loading here the dashboard component of my environment, and here I will see my testplex configured. So we see that we have 1 feedmaster node and we have 1 execution JCC node with just starting up the memory consumption there. So yeah, should be on 2 CPU percentage now when it's actually up and running. So the next goal, if we just come back to our slides real quick, is that we have now installed that Helm chart. We have the deployments, and now we want to, we actually have the auto scaling as well. So now we want to get started with our nodes and see if we can actually do some scaling of them. So before we do that, let's just go back again to our Google Kubernetes dashboard here. If I now go to workloads, what I will be seeing is, thanks to that Helm chart, I will be seeing 1 JCC and 1 feedmaster pod. Both of them have just a single one, both of them, right? And that's why we now want to see what happens if we go and scale that up. So here I have a very, very simple pipeline that basically reads a CSV zip file from my local file storage, and then it just unzips that file and just uses a mapper here to just add some text. So it's a very dummy pipeline, but it's still going to consume quite a lot of both memory and processing power. So what I'm going to do is I'm going to refer that pipeline in a parent pipeline here. So here I'm just adding a sequence snap that has 1,000 output documents, which means that it's going to execute this pipeline execute snap 1,000 times. So each time it does that, it's going to load my load test pipeline and execute that one, which means that we're going to load that huge file 1,000 times. And And here I've also specified that I want to run this on my local Snaplex. And that means that as soon as I have multiple nodes within my Snaplex, which hopefully I will get if I scale up, then the pipeline execute will automatically load balance across those two nodes whenever there's a new pipeline, child pipeline that gets invoked. So let's go and execute this pipeline and see what results we are having on our auto-scaling environment. So now we can actually see here on our JCC pod here that it had decided to successfully scale up to 2 pods because the CPU resource utilization was over the target. And when we run get pods here, we can also see that we now have 2 execution nodes and 1 feedmaster nodes. And if we come into our dashboard here again, we're going to be able to see that we still have that feedmaster and execution node, but now we have an additional node. So if we wait a couple of minutes and pause our pipeline that generated that load, we will basically see that the number of pods will also scale down. So as again, our pods basically occupy an entire node, what we also expect to see, if I go here back into clusters and I then go into our SnapLogic cluster, what I expect them to see is that obviously our default node pool still only has that single node, but now we actually have 3 number of nodes. So not only did we scale and increase the number of pods that our deployment requires, but also the number of nodes that are needed effectively to support those pods. So we can see here that we have 3 different nodes, each of them effectively supporting a single pod. And coming back in here and running kubectl get pods, we now see that we only have 2 single pods here. And if I go back to our workloads and I go into our JCC here, if I just hit refresh button, what I'm seeing here now is only 1 single pod. So after a while, we managed to also scale down to the intended minimum 1 replica of the execution nodes. And subsequently, if I go in and have a look at my cluster again here, if I come into the number of nodes here, we still have 3, but what we will be seeing is that we will be automatically taking that down as we do no longer need to support 3 different nodes. So in a couple of minutes, this will all come down to number of nodes as being 2. And that's the end of the particular demonstration. So just to kind of recap what we've done, we started by creating a Snaplex. We then downloaded the Helm chart that we got from the SnapLogic documentation. We then downloaded the Snaplex configuration specifically for our Snaplex that we created. We then edited the Helm chart. We added the config URL that we downloaded in step 3 into the values.yaml file. We then also added and changed rather the resource requirements for our 2 pods. Then we created the initial Kubernetes cluster that was called the default pool. And then we created a separate node pool that was supposed to support our actual Groundplex deployment. Then we installed the Helm chart, meaning that we created both the pod for the feedmasters and the execution nodes. We also then applied an auto-scaling policy, which meant that if any or the JCC pod went over 50% of the CPU, then we would add another pod, and effectively also another node. So we executed a pipeline to increase the memory and the processing demand on the nodes in order for us to actually scale up. And then we also demonstrated what it looked like when we were about to scale down. So first, automatically removing one of the pods, and then after a couple of minutes, we will have the node terminating as well. And that's the end of this demonstration.